we are working on properties of exponents for the second day. Today we're going to be raising a power to a power. So inside the parentheses you're going to have an expression and it's going to be raised to the exponent part. The exponent tells you how many times you're technically multiplying whatever's in the parentheses by itself. So over here you'll notice that 2 to the third power appears 4 times and it's being all multiplied out. And then once it's written like this, from yesterday we learned that we can take and add your exponents. So 3 plus 3 plus 3 plus 3 equals 2 to the 12th, which is 4,096 overall. So this next one is x to the 4th, and that's happening 2 times. So it's x to the 4th times x to the 4th. So realistically, that is going to be x to the 8th power when we add those two together. For the next one, it's x squared y 3 times. So 1, 2, 3. We combine the x's to get x to the 6th. We combine the y's to get y to the 3rd. So it's x to the 6th, y to the 3rd. The next one is 2x cubed, and that is going to happen 5 times. Once you write that out 5 times, we're going to take the number out in front, the 2, and we're going to say there are 5 of those being multiplied, so that's 2 to the 5th. And for the x's, if we count up by 3's 5 times, we get 15 of those. So then afterwards, you're looking at this and saying, well, 2 to the 5th, we can simplify that. It's going to be 32 x to the 15th. This next one is negative 2a to the 3rd, b to the 4th, 3 times. And so looking at this, we're going to take all of the coefficients. Negative 2, 3 times being multiplied is negative 2 to the 3rd. We have 3, 6, 9 a's and 12 b's. And so negative 2 to the 3rd power is negative 8, a to the 9th, b to the 12th. And you might be saying, well, okay, that's a little bit annoying. Looking at this next one, x squared to the 40th power, I don't want to write that out 40 times. That's going to just take forever. So isn't there a shorter way? And there is. There's a shorter way. If you look at these numbers, x to the 4th squared, and you compare it to your final answer, 4 times 2 is 8. Let's look at this one here. If you have a 3 being raised to the 5th power, or a third exponent to the 3rd power, then to the 5th power, looking at your answer, it's 15. So the shortcut here is you're going to multiply 2 times 40. And so this is going to be x to the 2 times 40, which is x to the 80th. It's going to save us from writing x squared 40 times. So when you have a power to a power, you're going to multiply the exponents. Again, notice we're saying exponents. You don't just multiply the numbers. So for instance, looking at up here, I'm going to highlight this in blue. This is 2 to the 1st power being raised to the 5th power. So you're really raising 2 to the 5th power as well, because you're doing 1 times 5. So be careful if there's a number. I would pretend that there's a 1 as your exponent and multiply the exponents, not just numbers. So let's try a couple of these examples. So here we go, x to the 5th to the 3rd power. We're going to take these and we're going to multiply them. So it's going to be x to the 15th. For this next one, we're going to multiply each of the exponents inside there. So it's going to be x to the 8th and y to the 12th. For example 3, we're going to take and we're going to multiply the 4 times the 3 to get n to the 12th times n to the 5th. So now here you're going to notice it's a combination of this new rule and the old rules. So what we're going to do is we're going to take and we're going to add those together to get x to the 17th. So for example 4, it's 3x being squared. So again, I'd think of 3 to the 1st power because we're going to distribute the square to the 3 as 3 squared and x squared. And then you see if anything simplifies further. 3 squared is 9 and x squared is just x squared. We're going to do the same thing here. It's negative 6 that is being squared. and then also x to the fourth that's being squared, so you multiply that. And then negative 6 squared is 36, x to the eighth. So if you haven't done this yet, I would go ahead and pause and try the next couple on your own, see if you can do them, and then come back. For number 6, we have 4 squared, x to the 6th, and y squared when you distribute that square to every base in there. And we're going to simplify, so it's 16 x to the 6th, y to the 2nd. So this power to the power rule also works with fractions. You're going to distribute this exponent to every different base in the numerator and in the denominator. So it's 4 cubed, a cubed, and 5 cubed. So you can do 4 times 4 times 4 to get 64. And you can do 5 cubed to get 125. Number 8 is similar. We're going to distribute the square to everything here. When we distribute it to b to the 5th, we are multiplying the exponents. And it's going to be 4 to the 2nd power when we multiply the exponent of 1 times 2. So it's b to the 10th over 16. So we're going to do the same thing on this next one. We're going to distribute the 4th power to each base. 2 to the 4th power, b to the 4th power, over 3 to the 4th power, and c to the 8th power, because we're multiplying there. So you do 2 to the 4th power to get 16, b to the 4th power, over 3 to the 4th power is 81, b to the 8th. So power to a power, the shortcut is to multiply the exponents. We're going to deal with negative exponents. So sometimes when you take and you use your division rules, subtracting this, it's x to the 2 minus 5, you get x to the negative third. So sometimes using your division rules, you get negative exponents, but we can't have negative exponents. So we need a different way to write it. So if we take and expand out x squared over x to the 5th, we can see that 2 of the x's are canceling out, which means we have nothing in the numerator and 3 x's in the denominator. So this x to the negative third has to be the same thing as 1 over x to the third. That's how we can get rid of negative exponents, is by moving them down to the denominator. So for instance, x to the negative a is going to become 1 over x to the a. Sometimes we have a negative exponent in the denominator. We have to take and we have to move it from the denominator up to the numerator. And now when we move it, it's going to become a positive exponent. So that becomes x to the a. So let's try a couple of these together. So number 1 here, we're going to go ahead and figure out what is being raised to the negative power. Right now it's just the x that's being raised to the negative third power. So the 7 stays where it is. The x moved down to the denominator and becomes positive. For number 2, the a has a negative exponent. That's in the denominator. It's going to come up in the numerator. The negative 5 is just a number. It's not an exponent. It's technically negative 5 to the first power, so it doesn't move. So it's negative 5, a to the 4th. For number 3, there's 2 things that need to move. Anything that has a negative exponent, I would circle it first and move it. So we're going to move y to the negative third down, and we're going to move z to the negative 4th up. We're going to leave 2x alone. Z to the 4th is going to come up to the numerator, and y to the 3rd moves to the denominator, and then there's nothing else to simplify. For number 4, there's one negative exponent, so that's going to move down. We get 12 over negative 6, x to the positive 9th, and y to the positive 3rd. And then looking at this, there is one more thing that can simplify. 12 divided by 6 reduces. That's going to become 2 over 1. And so that's going to become 2 over negative 1 x to the 9th. and y to the third power. Take a moment and try number 5 real quick. So we're going to circle all of the things with negative exponents. The x squared, z to the 5th, and a to the 6th stay where they are because they're positives. Y cubed goes to the denominator. B cubed goes to the numerator, and so does c to the first power. After this, nothing has the same base, and there's no other numbers being raised to a power, so that's it. So number 6 here is mixing together some of our rules. You're going to see some things kind of getting mixed together. So this is what we just did on the last one, where we're going to go ahead and multiply anything that's a power to a power. So negative 2 times negative 4 becomes a positive 8. For the y's, negative 4 times negative 4 becomes a positive 16. For this next part, x to the 0 becomes 1, so it's gone. And we're going to multiply y to the negative first times 2. So we're going to do negative 1 times 2, which is negative 2. So step 1, take care of the exponent to the exponent power. Now we're going to combine. So we're going to add together. Since we're multiplying, we add our exponents. So it's x to the 8th and 14y. So y to the 14th. Some of these problems become very tricky. So what I would do is I would simplify any exponents, distribute your exponent, simplify the parentheses, distribute the exponent, take care of negatives, and then continue on from there. So in here, let's go ahead. We're going to raise everything to the third power. It's x to the negative third over y to the positive 18 when you multiply those. The x to the negative third has to move to the denominator. The y to the 18th stays in the denominator, and we need a 1 as a placeholder. For the next one, we're going to go ahead and raise everything to the power here. So it's 2 to the negative 2, x to the negative 2, and 5 to the negative 2. Anything that has a negative exponent is going to move, which in this case is everything. So 2 to the negative 2 goes to the denominator and becomes 2 to the positive 2. We have x to the positive 2 now moving to the denominator, and 5 to the positive 2 now moving to the numerator, and we can take care of these numbers now. 5 squared is 25, 2 squared is 4, and we have x squared. So for number 9, you notice how there's 2 a's and 2 b's there? We can take and we can simplify these first. A squared over a cubed means there's an extra a in the denominator. 2 of them cancel out. There's 1 left. It's left in the denominator. We also have 2 bases of b. There's 4 b's in the numerator, 2 in the denominator. So 2 would cancel out, and there's 2 in the numerator. So we can simplify or reduce those first, and then raise everything to the negative first power. So it's b to the negative second, a to the negative first, and then we can take care of those negative exponents. So it's a to the first over b to the second. This last one, we're going to raise everything to that negative fourth power. So it's 2 to the negative fourth, a to the negative 12th, and b to the negative fourth, all over s to the negative 16th. In this case, everything has to move, so it's s to the 16th over 2 to the 4th power, a to the 12th power, and b to the 4th power. And simplifying from there gives us s to the 16th over 16, a to the 12th, and b to the 4th. So thank you very much for listening. I hope this helped. Tomorrow, come on in with any questions that you have and we can go over them. Thank you.